Hello, in this chapter we're going to be talking about Newton's second law for particles. And Newton's second law in its most basic form is a relationship between forces and acceleration where F is equal to ma. Alright, so when we get into this, what we're going to do first is we are going to set up what's known as the one-dimensional equation of motion if we're working with a single dimensional problem. So this is just F equals ma directly. We plug in our known forces and our known accelerations. And then from there, we can branch out into two dimensions. And just like we had with kinematics, we've got some options for the coordinate systems that we work with. We can work with rectangular coordinate systems, we can work with normal tangential coordinate systems, and we can work with polar coordinate systems. So it's essentially F equals ma in each of those two directions, but those two directions we can kind of pick and choose what makes sense for our problem. All of this is going to be built on top of particle kinematics. So whereas the second law relates to forces and accelerations, kinematics, as we discussed in the previous chapter, relates acceleration to velocities and position. So between the kinetics, which is our Newton's second law, and the kinematics, which is what we talked about in the previous chapter, we can relate position all the way to things like forces. All right, so that's all we have in this chapter. Thank you for watching and hope to see you again.